Hello students, myself Archana Varode from Praveen Patel College of Diploma Engineering and Technology. In last video, we have already studied about how the behavior of wire under continuously increasing load, or it is also known as stress strain diagram. And in first point, we have already studied about the definition of elasticity. Elasticity means it is the property of material on which the body regains its original dimensions or regains its original shape and size when external force is released. But when continuously force is applied, then due to that, sometimes that body does not return to its original shape and size. After that, it changes into plasticity, or it shows the property of plasticity. And there are some factors on which the elasticity depends, and these are called as factors affecting elasticity. So first point is what is effect of stress, second is what is effect of annealing, third is change in temperature, and fourth is presence of impurities. Now we see one by one. Here first point is what is the effect of stress. As we know that when material is subjected to a large number of cycles of stresses, that means when continuously force is applied one by one, then at that time that body loses its elastic property even within the elastic limit. And as we know that within elastic limit, stress is directly proportional to strain. That means if the load is within limit, then at that time there is no permanent change in its shape and size. There is no permanent deformation. But when that force is applied continuously, then after that, that limit is beyond limit, beyond the elastic limit. And after that, that body changes its shape and size. And therefore, the working stress on the material should be kept lower than the ultimate tensile strengthening and safety factor. That means the working stress should be less than the ultimate stress, because we know that working stress means this is the actual practical stress present on the system, and ultimate stress means it is the maximum stress that the wire or that object can hold. And therefore that precaution is the working stress on the material should be kept lower than the ultimate stress. Then second point is effect of annealing. First we see what is by annealing process. This annealing, it is a process by which the material is heated to a very high temperature and then it is slowly cooled. And usually this process is adapted for the material to increase the softness and the ductility in the material. But if the annealing is made to a material and it results in the formation of large crystal grains, which ultimately reduces the elastic property of the material. That means due to the annealing, the elasticity property get reduced, that means decreases. Then third point is what is the effect of temperature. As we know that there are three steps of matter. First is solid, second is liquid, and third is gases. In solids, the materials are tightly bound to each other. There is a force of attraction and that force of attraction is very large. But when temperature of any material increases, then due to that that material or that molecules get separated, and due to that force of attraction decreases, and due to that elasticity decreases. See here, the elastic property of the material changes with the temperature, and normally the elasticity increases with the decrease in temperature and vice versa. That means elasticity increases with decrease in temperature, or we can say that elasticity decreases with the increase in temperature. For examples, first is the elastic property of lead increases when temperature is decreases, and second example is the carbon filament becomes plastic at higher temperature. So here this is the photograph which shows the effect of temperature on material. The next point is what are the effect of impurities. When we add any impurity in the material, then it produces variation in the elastic property of the material. Sometimes there is increase or decrease of elasticity depends upon the type of impurity added to it. That means it is not possible that when impurity is added, then its elasticity increases or its elasticity decreases. It depends on the type of impurity added to the material. For example, when potassium is added to gold, then its elastic property of gold increases. Second is when carbon is added to molten iron, then the elastic property of iron decreases, provided the carbon content should be more than 1% in iron. So here, this is the difference here. First is when potassium is added to gold, then its elasticity increases. But in second example, when carbon is added to a molten iron, then its elastic property of iron decreases. And therefore, here we say that the increase and decrease of elasticity depends on the type of impurity added to the material. Then fifth point is what is the effect of recurring stress? Here recurring stress means it is also called as repeated stress. That means if the repeated stress is applied on the same body, then softening of material takes place and increases the plasticity. That means it does not behave the property of elasticity. It changes into plasticity and hence decrease the plasticity. So here this diagram shows that here what is the effect of repeated stress, recurring stress on the material. Here continuously hammering, due to that it bears the property of plasticity. That metal does not return to its original shape. So here this is the summary of what are the factors affecting elasticity. First is hammering and rolling. As we know that crystal grains break up into smaller units by hammering and rolling, and this results in increase in the elasticity of material. Second, we have already seen annealing. The metals are annealed by heating and then cooling them slowly. Then annealing results in decrease in the elasticity of material. Third point is temperature. The intermolecular forces decreases with the rise in temperature and hence the elasticity decreases with rise in temperature. But the elasticity of inverse steel, that is alloy, does not change with change in temperature. Last is addition of impurities. Due to the impurities in a material, elasticity can increase or decrease, and the type of effect depends on the nature of impurities present in the material. Now we solve some examples on these points, that is Young's modulus or stress and strain. First example is a wire of length 3 meter extends by 3 millimeter when force is 2 Newton is applied to it, and calculate stress produced in it if Young's modulus is equals to 2 into 10 raised to 11 Newton per meter square. First we write the given values from the numerical. Here the given value is a wire of length, that means original length is 3 meter. It extends by 3 millimeter. That means this is the extension produced in wire. Therefore, small l is equals to 3 millimeter. And when we convert it into meter, we get 3 into 10 raised to minus 3 meter. And force of 2 Newton is applied. Therefore, F equals to 2 Newton. And we have to calculate stress. And when that Young's modulus is given as 1 into 10 raised to 11 Newton per meter square. Therefore, we use the formula Y equals to stress upon strain. But here Y is given and here we can calculate strain because small l and capital L is given. And therefore, here formula becomes stress is equals to Y into strain. Cross multiplication here. Then we write the formula for strain as small l upon capital L. Then put the values of Y and small l upon capital L. Therefore, we get stress is equals to value of Y is 2 into 10 raised to 11 and small l is 3 into 10 raised to minus 3 upon capital L is 3. Then when we take division, then we get here 3 upon 3 get cancelled. We get 2 into 10 raised to 11 into 10 raised to minus 3 and therefore 2 into 10 raised to 8 Newton per meter square. And that answer is stress is equals to 2 into 10 raised to 8 Newton per meter square. Then second example, calculate Young's modulus of elasticity for a wire having length 100 centimeter and cross sectional area is 1.96 into 10 raised to minus 5 meter square. And the wire elongates by 2 millimeter when subjected to a load of 10 Newton. Therefore, here first we write the given values from numerical. Here we have to calculate Young's modulus. Then length of wire is given as capital L equals to 100 centimeter. And when we convert it into meter, we get 100 centimeter equals to 1 meter. Then area of wire is 1.96 into 10 raised to minus 5 meter square. Then extension is small l equals to 2 millimeter, that means 2 into 10 raised to minus 3 meter. And force is applied, that value is F equals to 10 Newton. And here we have to calculate Young's modulus. Therefore, formula for Young's modulus is Y equals to capital F into capital L upon capital A into small l, where capital F means applied force, capital L means original length of wire, capital A means cross sectional area of wire, and small l means it is the change in length or extension produced. Then we put the values. We get Y equals to value of F is 10, value of capital L is 1, then value of area is 1.96 into 10 raised to minus 5 into small l, that is extension is 2 into 10 raised to minus 3. Then when we solve this numerator and denominator, we get the final answer as Y equals to 2.54 into 10 raised to 8 Newton per meter square. That's all about today's video. Thank you.